So another case where the theorems, I think, give us an important guidance to how we do asset pricing, how we evaluate asset pricing, how we think about what it all means. The mimicking portfolio theorem, which we've used a couple times, and let me make it explicit. Suppose you have a pricing model. In fact, suppose that the consumption pricing model worked perfectly. So price is expected discounted payoffs using consumption growth to the minus gamma. Well, then we can always represent the same prices with a mimicking portfolio. A mimicking portfolio is the projection of that discount factor onto the space of payoffs, a traded portfolio that carries all the pricing information. How do you do it? Well, you run a regression of M onto the space of payoffs with a residual. Residuals are uncorrelated with right-hand variables by construction. So that's the same thing as projection of M onto x times x, which is just our friend x star. So if this model worked, we could construct an x star just by running a regression of marginal utility onto the space of all returns. And that x star would generate prices exactly as well as the original consumption growth model, the mimicking portfolio theorem. Now, what does that mean? There's a portfolio that prices just as well as the true discount factor. And we also know from our last fishing theorem that there's a lot of portfolios that will price a whole lot better in a sample because they fish their way around to something closer to sample mean variance efficient. Furthermore, if consumption isn't measured that well, then the mimicking portfolio for consumption will price even better than true consumption and the true discount factor, simply because that can be much better. Asset returns are much better measured than the true underlying discount factor. So what do these easy to see theorems tell us about how we do asset pricing? First, it tells us a common exercise. If you have a utility function or consumption growth, a common exercise is to run a horse race. Does my discount factor beat the Fama-French three-factor model or whatever portfolio-based model is current? But that's a silly thing to do because we know there's a portfolio-based model that does just as well, the mimicking portfolio, and we know you can fish around and find better portfolios, and we know that portfolios are better measured anyway. So doing that horse race is silly. Really, the status of a consumption-based model is its greater theoretical purity. What we should be doing, which makes more sense, is to ask whether Fama and French's factors are the discount factors for some model. Does our model explain why those things work? That's a much more reasonable thing to ask. But a horse race between ad hoc factor models and macro-based models just doesn't make any sense at all because of our mimicking portfolio theorem. On the other hand, what does the theorem tell us? Using the mimicking portfolio is right for most practical questions and would be right even if we had the true model, which we don't have. If you had the true model, you get consumption data quarterly at best. You want to price something in sort of real-world pricing on a day-by-day basis. You want to find out whether the latest anomaly is just a version of all the other anomalies we've seen. For that kind of purpose, you don't need to go back to the deep underlying discount factor. You use the mimicking portfolio because that has good data on a daily and weekly basis and can let you know, is something new just a version of the old ones we've seen? That's an example of a practical question for which using the mimicking portfolio would be better even if we had a perfect model. But of course, using mimicking portfolios, using ad hoc factor models, they can't do anything to answer the rationality question, because for that you need to tie it back to real macroeconomic risks. So these are examples why these theorems and alternative representations are important. They guide you to thinking about what the heck you're doing and to using the right kind of model for the question you have at hand. We're not always arguing about rationality. We're not always just trying to price one thing given the price of other things. We're not always fishing for anomalies. Use the right model, ask the right questions, and these theorems can be an important bedrock for you to do that.